But yeah, first of all, do you want to introduce yourself? Talk about about you and NeuroTech Reports, and then obviously you're in a wheelchair too. So do you want to talk about that?
Yeah, we can talk about that. So, I'm Jennifer French. I'm the executive director of NeuroTech Network, which is a nonprofit that focuses on education and advocacy of neurotechnology devices, therapies, and treatments for people with neurological conditions. I'm also the senior editor and associate publisher for NeuroTech Reports, which is the leading news and analysis for the neurotechnology industry.
And you have some experience with brain-machine interfaces, right?
Well, I have a lived experience, yeah. So I had a spinal cord injury back in 1998, and about a year and a half after that, I joined a clinical trial in Cleveland at the Cleveland FES Center, having a neural prosthesis implanted. So as a person living with tetraplegia, I am basically paralyzed from my neck down. So I don't have motor function of anything that's below my injury point. So I do have the use of my arms. You see me using my hands, but I don't have all the intrinsic muscles, so I can't do all the fine motor tasks with the hands. And using and living with this neural prosthesis, I mean, I've had it for nearly 20 years now. When you think about that, that's a long time. It's integrated into your life. You use it all the time. Your body starts to crave it. So having that lived experience and living that way, right, and integrating it into your life. I had an aha moment when I was actually at a Neural Interfaces conference way back when, I think it was 2000 or 2001, and we had a panel of people that were at the time really when the industry was still very young. And there was a woman with a deep brain stimulator, there was another woman with a cochlear implant, and there was another gentleman with a hand prosthesis, and then myself. And we were all talking, and it was this aha moment that, you know what? Really, we're the few. A lot of people living with these neurological conditions don't know about the technology that's available, nor how to access them. So that's kind of was the spark of the nonprofit for us to kind of focus on that. So the world has changed, obviously, since then, in a good way. So it's good that this whole industry is starting to mature, and we've watched it mature over the years. And we're seeing it where people are getting more engaged, where research is becoming more engaged. And really, we're starting this whole movement of consumer engagement into this industry. It's been really taken hold in the pharmaceutical industry, but we're still very on the early stages in the medical device and particularly in the neurotechnology space.
Yeah, I would say so too, and it's starting to reach an inflection point a little bit. But I don't know, I feel sorry about having to bring this up, but do you want to tell your story about how you got the injury? Because it's kind of epic.
Don't feel sorry for asking. We all do. I'm obviously not shy talking about it because I wrote a book about it. So my book is On My Feet Again, and it really kind of talks about my journey from injury to, becoming one of these bionic pioneers, becoming one of the first people to get these types of implants. So it was 1998, and I was working, at the time it was the dot-com era. So if you can imagine at that time, there was a lot of startups, there's a lot of activity. If you were in the tech business, it was really kind of vibrant, and it was a really fun place to be. And I was working for a company in southern New Hampshire, and the company went public. We brought it public, and this was my first weekend off. And so we rented a house up in one of the ski areas, and we went on a midnight run, which was kind of our tradition to do. There were about a dozen of us that slept on our skis and our snowboards and went down the mountain, and it was beautiful because it was a full moon, and the trails are glowing. So it's this awesome experience, right? So, and we had a pickup truck at the bottom of the mountain to pick us up. So 11 of us made it down. I didn't. I hit a patch of ice, went down a 40-foot embankment, kissed a bunch of trees, and suddenly came out as a tetraplegic. So at that point, your life it changes. I mean, everything that you did that morning, you can no longer do again. And it really is kind of this journey of getting yourself and getting your life back, because it's basically stripped away from you.
Wow, that's incredible. And then, I mean, you were doing such a active thing, and then you didn't want to, I don't know, sit by when there were treatments available. Do you want to talk about this? You said a year and a half later, you were able to do a treatment, but they didn't want to take you, right?
Right. Yeah, that's so true. So, when you leave the hospital with a spinal cord injury and you're sent home, it's kind of like, that's it. There's no cure for spinal cord injury. You do what you have to do to get by, and that's it. So you're really kind of left off this cliff. Since then, there's support groups and things have changed, over the years, but still there's no cure for spinal cord injury, and today there still isn't. So what's next? How do you keep your body healthy? I think one thing a lot of people forget is that with these conditions, it's not just the paralysis, it's all the secondary conditions that come after that can kill you. It's, the bladder infections, it's the muscle atrophy, it's the osteoporosis, it's the pressure sores, it's all of these things that can really deteriorate your life, not necessarily the paralysis. So you're constantly in this fight to keep your body healthy. But I also came to this revelation of, okay, there's no cure, what's next, right? So there has to be something. So I started to look into research and said, if I can't sit on the sidelines and do nothing, right? I can sit in the side, or I can become an active participant and try to move science forward. So that's when I decided to look at clinical trials. And ironically, I was using an FES bike, and at the time, FES bike is surface stimulation on a cycle, and it helps to keep your body healthy and your body moving. And at the time, people didn't have them in their homes. I had to drive down to Boston to be able to get it. And I was going through an appeal with my insurance company, trying to get access and more treatments so I can still go and use this piece of technology. And in writing my appeal, I found this research group in Cleveland called the Cleveland FES Center, and was trying to find some research and asked them to send me some stuff. And they said, oh, well, by the way, we've got these clinical trials going on as well. Oh, okay. Well, that sparked my interest, right? And they ended up having this implanted neuroprosthesis for lower extremities. So I made a video, the old-fashioned videos.
Yeah, like a VHS.
Yeah, no, it was the little ones. But still, I made a video and I sent it off to them with a letter saying, hey, listen, I'd like to join your clinical trial. And, I had to hire a personal trainer to be able to put on these long KFOs. They're these plastic braces that go up to your hip, down to your foot, so I can get up and at least try to move. So I was active and, trying to make the case of why I meet the inclusion criteria for this clinical trial. And they wrote back and said, well, thank you for applying, but no. And part of their reply, they said, well, we've never implanted a woman, so we're not accepting women into the clinical trial. And of course, that sparked me and said, well, wait a minute. 20% of women.
Did you hear how I got injured, actually?
Exactly. Well, yeah, and I made the case back to him and said, 20% of spinal cord injuries are women. And sooner or later, you've got to implant a woman because we're part of the population. And rightfully so, they did their background research. They had real concerns about implanting into the abdomen in a childbearing woman, what that would do, and what kind of precautions had to be made for that. And they did that background research and got back with me, and eventually they let me into their clinical trial. Yeah.
Wow. So yeah, do you want to talk about the trial and everything like this, and maybe who you worked with, like maybe some previous guests on the show, and the process and everything like this, going through all these steps?
Yeah. So we flew to Cleveland and went through the first stage in terms of the evaluation to see if you met it, and you had to send all of your medical records, etc. So. The principal investigator in that trial is Dr. Ron Triolo from Case Western Reserve. And at the time, Hunter Peckham was the director of the FES Center. So, in meeting all of them, it seemed like a really, a viable group. And of course, I had to do my background research. I wanted to make sure that they were funded and that they were a viable research team and that they had real outcomes and there were papers that were written from them. And, doing that due diligence as a clinical trial participant is really important because I think we forget sometimes that there are scam clinical trials out there. And there's a lot of medical tourism going on that try to mask themselves as clinical trials. Hey, come on, we'll put some stem cells into your spine and we'll zap you a little bit with some electrical stimulation if you pay us $20,000 or something like that. So that really happens in the world. So as a participant, to do that background research is really important.
That seems especially evil, to take advantage of, I don't know, people who just want to get better. That's pretty low.
It's extremely low, but it happens around the world. And it's really sad that it happens, that we have to do, this kind of due diligence. Clinicaltrials.gov does a really good job of streaming out a lot of those. So it's a good resource. However, some of them still get through. So it's at a point where you really need to do a buyer beware. As it's sad because a lot of us living with long-term neurological conditions, there's no cure. We don't have anything else, so we're constantly looking for how do we improve our lives, how do we make our conditions better, right? How do we contribute to science? So that's always kind of a key thing. So getting back to the into how I joined the trial in Cleveland, eventually we passed all of those inclusion criteria and passed all the interviews, and they put together a surgery date. And at the time, we had to move to Cleveland. You had to live in Cleveland. So my boyfriend at the time, my now husband, we picked up and moved, and I was still working for the tech company, and they were extremely accommodating. So we set up a home office in Cleveland, so I was able to work remotely from them. And I joined the clinical trial and went through the implant process. That first surgery was 7.5 hours.
Wow.
So it's a pretty long surgery. But it's you wake up in the hospital and the day that all the engineers come back in, and of course there's a physical therapist. I think there's one piece I left out is that you go into this surgical room and there's surgeons and there's engineers everywhere and there's nurses and operating staff. But the key person in that room is the physical therapist, because as they're implanting these muscle electrodes, they turn it on in surgery, and the physical therapist is the one that says, yeah, that's the movement I want, or no, that is not the movement I want. And then they try to find it, do the right placement of that electrode. And then once they find that right movement, they suture it up. So they're very diligent on, even when they're doing the implanted process, they're just not guessing. They're actually stimulating and seeing where do I get that muscle movement and how do I get the best return.
And so what was the device and what was the aims of it as well?
Mm-hmm. So it's at the time it was an 8-channel system. In fact, I still have it today. It's the IRS 8. And it implanted into my quads, my hamstrings, glutes, and lower back on each side, so bilaterally. And so all of that is encompassed inside of the body. And then there's an external control box that has all the circuit boards and the battery power. And it communicates with the implant using RF power, or RF frequencies. And you send a signal through the external control, and it goes into the implants. The implant, which looks a lot like a pacemaker, decodes it, sends it to the electrodes, and the electrodes fire up and get the type of movement that you want. So that's how it basically works. But the outcomes that they're looking for, it's called the stand and transfer system. So they were looking to be able to stand using the system and be able to transfer in and out of your wheelchair. Which, people say, well, how come aren't you taught wheelchair skills in rehab? And we are, but there are transfers that you're unable to do, particularly with my high level of injury. So with this system, you're now able to do those types of tasks. So that was the initial aim of what they were trying to achieve what they've found out over the years is that there's all these other functions that they can add on to it. And now they have a study that's just for trunk. So now, that's just on your trunk control. So you think you're sitting up pretty straight right now, right? So if you have none of those muscles, you can't do that, right? If you want to reach up and want to be able to use your arms bilaterally, if you don't have trunk control, you can't do that.
Because you have an imbalance, right? So you'd kind of fall over.
Mm-hmm. Exactly. So, so this opens up the amount of people that can actually use this system, right? And that it allows for exercise so that you can build those muscles that you're constantly sitting on to help prevent pressure.
And so how are you sitting up? I mean, or how do people sit up otherwise? I mean, do they have to get strapped in? Or
usually they're strapped into their wheelchairs. Yeah. Mm-hmm. Mm-hmm. Yeah, exactly. So when you think about that, that's the function that you get out of it. So I've been using that 8-channel system. I was initially implanted in November of 1999. And I used that system for, over 10 years. And with great success. And it started to deteriorate. My standing started to deteriorate. And that's when I went back to the team. They had another implant that they had created, which was called the IST-16, which was a 16-channel system. And they had a new electrode. It's now a nerve electrode called a cuff. So it wraps around the nerve, and it has different channels on it. So that was the first time I met Dr. Lee Fisher, who's now at the University of Pittsburgh. So he was actually working on his postdoc on that project with Dr. Ron Triolo. And so that was, hey, we can implant this additional system. We can put in these electrodes. We can help, augment what's kind of failing on your RSA, and we can give you some additional function as well. So that kind of revision, I call it Gen 2.0, took place in 2010. Yeah, so in 2010, now I have 2 implants. I have both of them on either side of my abdomen.
So is there training involved in this? I mean, and like lots of physical therapy, or how would you describe that process?
Yeah, so when I was first implanted, you wake up in the hospital and all these engineers come into your room, right? So
she's awake.
Yeah, they're awake, and they bring all this equipment, and they're like, okay, we're going to have it test out first, right? So here they put the coil over the implant, and they're testing the system and looking at the different thresholds. And the first time that they turn it on, you can see your leg kicking out, right? And there's nothing attached to it. You can see your muscle contract, and you're kicking out your leg. It's the coolest thing in the world, So if you've been paralyzed for a while and all of a sudden you see your muscle working, it's a really cool feeling. So that's, they do a lot of testing. They set the thresholds. And yeah, there was, when I was first implanted, they gave me exercise plans. I spent 3 months building up those muscles and exercising for 3 months. They brought me back, and then I was able to do my first stand. And do some therapy from there. So that was kind of the process to be able to get to the standing piece. Then you bring it home and you start to integrate it into your life. But being part of a clinical trial, you constantly come back because they constantly have lab projects and those types of things. So you volunteer a lot of your time to get into the lab to kind of help improve this system, and you become part of the research team. There's things that you see or that you use in the outside world, and you bring it back to the research team and say, hey, listen, can we correct this, or can we make this better, or this is what I'm seeing, etc. So really you become a part of the team and a part of helping to improve the device.
Honorary PhD.
Yeah, well, I don't know about that, but I could be an honorary pain in the ass too. So.
Were you causing problems for them, or what?
I wouldn't say I was causing problems, but I think it's a real active participant will constantly give feedback to them, and sometimes that feedback isn't always positive, right? So, but that's good. I mean, that's how we improve our devices and we make them better. And there's a lot of people that are involved in these clinical trials to advance our devices, particularly as we go into humans more and more. And they're the ones that are putting their bodies forward to make a difference, right? So we think of the exploration of flight, and we celebrate all those pilots that were able to do it, right? Or we think about going to the moon and what we do for astronauts, and we celebrate them. These are people that are in this implant world where we're really the ones on the front lines putting our pioneers. We're putting our bodies forward for the advancement of science. It's no different from what an astronaut did, right?
Wow. And so with this second implant, how is that different and how is that similar?
Oh, so it's well, it's similar where I'm able to stand and get some of that main function.
I mean, I guess how's the technology progressed? Is there some improvements, or do you think that it'll last longer as well, or what?
Well, that's yet to be seen. We don't know, right?
We'll find out.
We'll find
it's only
out.
been 10 years, right?
You're right, right. So, so it's 2018, right? So, things have changed. So the electrodes. This is one of the things that we're trying to solve, and that was part of the cuff project. Is because the cuff wraps around the femoral nerve, and you have all these different electrodes. And one of the problems, the systemic problems with stimulating a muscle, is that we stimulate it and put it on as hard as it possibly can for a contraction. Well, fatigue will set in, just like any human, right? And if we over fatigue, we can do damage to the muscle tissue. So how do we overcome that fatigue? How do we, change some of the stimulation patterns to be able to give some of the muscle tissue a rest, but still be able to get that function? And that was part of the research project for the cuff electrode. And really, how do we design these stimulation patterns so that we can get more use out of it? So typically when someone stands, the first muscle that wears out is your quads. So by wrapping it around the femoral nerve, we're looking at all those 4 muscles that are in your quad. Actually, technically the 3 muscles, because one of them actually makes a hip flexion. So really, how do we do those patterns to be able to give a little bit of extra time for people? So I think that's still an unanswered question, and it's still kind of ongoing research as we're trying to figure that out. Yeah.
Interesting. Wow, that's really cool. Well, yeah, I mean, I think maybe we can have this first part be, about this, and then we can talk about the NeuroTech reports and the future and everything like this. So in the first part, we talked about kind of your injury and then your personal experience with brain-machine interfaces. But then I really want to talk about NeuroTech Reports, which is a publication that you started with your husband, right?
Yeah, no. Well, NeuroTech Reports was existing actually, and Jim Cavuto is the founder of NeuroTech Reports, and he is not my husband.
Okay. Yet.
No. I'm very happily married. I'm very happily married to my husband. Thanks. But so he started actually in 2001, and I met him at one of the Neural Interfaces conferences. And about 3 years ago, I joined on with him with the business. It's a for-profit business. So really, the kind of the structure of NeuroTech Reports is really to do kind of the industry reporting and analysis specifically for neurotechnology devices. So we're not interested in neurotech, pharma, or any of those other kind of areas of neurotech, but we're very focused on devices. So we have a monthly publication that we put out. We have market research report that we put out, really looking at the projections for the industry. We have custom publishing that we do for either investors or companies that are looking at getting into the space, or for companies that are developing devices. We'll do that. We'll do some custom reporting for them. And then we also run an investor meeting. So we have the NeuroTech Leaders Forum that takes place in San Francisco every fall. And really, it's a forum where we look at some of the key issues that are in the neurotech industry. But we also, it's also an investment meeting. So this is when we bring in startup ventures. They can do their pitch to the investors and really kind of meet face-to-face with a lot of the investors in the space, particularly for startups that are looking at doing some type of series round of financing. And this past year, we just started the inaugural Bioelectronic Medicine Forum in New York City. Again, the same format, but it's only a one-day format, but we're very focused on bringing in the investors in bioelectronic medicine and really working with some of the startup ventures in this space and giving them a platform to meet with the investors and allowing them to do their pitch and really kind of making those introductions to the investment community.
Wow, that's amazing. I want to attend all of those things. But so you okay? So you've only been there for a few years, but what has your experience been with kind of the growth of the market in this? Because it really does seem like we said, and I think in the last episode, like there's an inflection point. Like somehow something is allowing this to go faster than it used to go. Like from, I don't know, the 70s to the 2000s, that was very slow. And then now 2000, 2010, and then now it just seems like more people are piling on. So how do you see this?
Yeah, there's been a lot of kind of key investments made that gets us to the point where we are today. Just 5 years ago, one of the key things that took place was the Brain Initiative that happened in the United States. There's also a parallel project in Europe called the Human Brain Project. And actually, today there's now brain projects around the world, and they're now starting to start this consortium of brain projects that are happening around the world. So you're starting to see the scientific community come together. But coming back to the U.S., it was 5 years ago we did this brain-computer interface, or brain initiative. And with this brain initiative came investment, and that investment was on the research side. So it really helped to push the National Institutes of Health, the NIH, to start to do some key investments in this space. It also helped to push DARPA into investing into this space as well. So here we got this, 5 years ago, we have this key investment into research, into how do we build the tools, how do we build the technology that's in this neurotechnology space, because we see, and rightfully so, is that neurological conditions are a growing population, especially as we start to age. I mean, you think about it, we have dementia and Alzheimer's, right? But we also have Parkinson's disease, and we have, epilepsy that comes with it. And then DARPA's looking at, how do we do this for our soldiers? So we have people coming back with brain injuries, and they have a lot of seizures. And how do we care for those soldiers that are coming back with paralysis? So here are all these issues that they're facing, and how do we invest in the technology to help bring it forward? So that was 5 years ago that we saw this type of investment. What we're starting to see now is that all of this technology is now developed and it's starting to mature. It's at an inflection point where we need to start doing some technology transfer. And there's a foundation out there called the Coulter Foundation, and they made some great investments in bioelectronic engineering. And they went through their vetting process, actually through a 2-phase process, and they now have 16 institutions where they put money forward into investing into bioelectronic, biomedical engineering. And that helped and that was very focused on translation. So they started to invest in this translation space. So now we're starting to see these companies and these ventures starting to come out of the lab and into the marketplace. And that's kind of the inflection that we're seeing in terms of the growth of neurotechnology.
That's really cool. It's like the private investment into the research kind of spurred up everything. So I had always thought it was kind of a technology based thing, but maybe the private investment saw like, okay, we're gonna be to the point that we need to be in terms of technology, maybe like computing power and everything like this, and then that, according to this story, is like that kind of launched everything else. That's actually kind of exciting. I mean, what kind of investment amounts are we talking about? Like millions or billions or trillions of dollars? Or what?
We're talking about billions of dollars, especially when you look at it around the world. But no doubt, the advancements that we've seen in technology have bled over into this space. The advancements in materials, we're learning that we can do less harm, make less invasive devices. We can actually have some real viable treatments through the technology that's been created. But that technology can't drive forward without the dollars behind it, right? You still need the investments to run those labs. You still need the investments to be able to hire the quality people that can look and try to solve these problems. So that investment actually helped to push it forward.
Okay, so what do you do? Like do you go through all these publications? Do you read all these scientific papers and see, okay, this one has a potential, this one has legs, this one doesn't, or what do you do exactly?
Yeah, so we go to a lot of conferences. So we try to find kind of what's the leading edge. We do look at published publications to see what's happening, to keep our pulse on the research. But there's also a key thing of keeping a pulse on the industry. So we've seen investors, we've gotten through this world economic slump, and now investors are now coming into this space. And in fact, we're seeing new investors come into this space, which makes it really exciting. So not only do we have technology that is ready to be transferred out, that's ready to go into humans, that's ready to go onto the marketplace, but we're also seeing investors willing to get into this space, right? So now we're starting to see the investment from the pharmaceutical industry is now starting to come into the space of neurotechnology. The investors from some of the other kind of tech world, internet world, are now starting to come into this space. So we're really starting to see these investors wanting to have a fingerhold into this business, and how do we grow the companies forward to be able to get access. Because in the industrialized world, people don't get access to devices unless it goes through a commercial entity. If it doesn't go through a commercial entity, people don't get access to it unless they're part of a clinical trial.
So do you think the time is right, or do you think it's just hype, or maybe they're a bit too early, or do you think like they hit the iron while it's hot?
I am a person living with a condition. You can never move fast enough, right? We can never move fast enough.
Exactly. Should have been 10 years ago.
Exactly.
20 years ago.
Yeah, in my view. But really, we're starting to see that population grow. We're starting to see systemic issues with Alzheimer's and dementia. And how do we solve that problem using the type of technology that we have? How do we improve that, right? So, I mean, we're at a stage now where we're trying to get better technology that's less invasive, that's more marketable, and how do we get it through the regulatory process? How do we get it through the reimbursement process? And, we looking at the industry, it's really exciting. I mean, we're projecting now that in 2018, the NeuroTech business will be about an $8.4 billion business in 2018. But the bigger story is that by 2022, we're projecting that it's going to be $13.3 billion, right? So that's a compound annual growth of about 12%. Tell me where you're going to get that in another tech business, right? And when you start to parson out and you start to segment the neurotech industry, so we actually segmented into 4 spaces. We segmented into neuromodulation, neuroprosthetics, neurorehab, and neurosensing and diagnostics. And when you start to parson it out, you start to see some really exciting growth, some pockets in the industry that are growing just exponentially. The bioelectronic medicine space.
A personal favorite topic of mine.
Right? It's a personal favorite topic of yours, right? So it's a growing piece of the pie. We're projecting that to be growing at a 26%, annual growth rate. I mean, that's a lot of growth in that space. And the investors are starting to say, yeah, we're willing to take that on. But one of the key things in terms of the investment that we're seeing is that investors are now starting to understand the medical device space, right? It's not quick to market. A medical device, no matter what you might hear in the press, takes a long time to get to market. And it takes a significant investment to be able to do that. And so investors are now having more of an appetite to be able to put in their investment, knowing that this is going to be a long-term, a long while before
like
they get their
10-year,
return.
20-year versus an Instagram turnover in 2 years, something like this, right?
Exactly. So, and we're starting to see that in real dollars. So when we look at the startups that are coming and starting to do some of their pitches to the investors, we typically used to see a Series A, maybe a Series B, maybe a Series C, and then they want to exit, or the company goes out of business, or they go public, right? Now we're seeing Series D. We've even seen a Series G, right?
Wow.
In financing, to be able to get to the point where you can get that device onto the market, reimbursed, and really turn into, a real commercial entity. But we've also seen a push and an increase in IPOs as well. So initial public offerings, where these companies are going public.
Do you want to go over all these terms? I mean, for people who might not understand it, might not be in the startup world, so about the series fundings and IPOs and all this kind of stuff.
Sure. So for a startup company, really they need some initial investment, and that initial investment is usually from an angel investor, right? Or they might get something from a tech transfer office, right? So to make that type of investment. they make that initial investment, then they have to put their business plan together. And now they need to have financing to be able to move that device forward, to be able to get through regulatory, to be able to build the business model, to build their management team, et cetera. And that's where they start to go out for financing. So typically they'll do their first round at Series A, B, C. It just goes down the alphabet, right? And typically when they want to do a series financing round, you put together a business plan, you put together how much you're trying to raise, and then you put together a pitch deck and you go out to the investors and say, listen, this is what we're trying to do. This is what we think is going to happen. This is why we think this is a good space. This is the market for it, and really make a good business case. So that's what, series rounds of funding that happen. So if they get to a point where they got to their point with the Series A, that financing starts to run out, they've got to make another round of financing happen, right? There's also areas for non-diluted financing, which is basically saying I'm going to a bank, or I'm getting out a loan, if you will, for the company to be able to keep get it going. So you're not giving away a stake in the company, but you're actually getting some financing in to be able to keep the company going. And then an IPO is an initial public offering. That's when a company decides to go public. They they create their stock, they do their round, and they go public to whatever stock exchange they decide to go out on, and they become a public company, and all that comes with that.
Oh, very cool. And so you're saying you're seeing a lot more companies go through this whole process, a lot of neurotech companies.
We're seeing a lot more startups, and we're also seeing a lot more companies go through more series of financing. Yeah. Mm-hmm.
Wow. And so what does that? I guess what does that mean for the field? I mean, is there? Do you think it'll continue? And maybe how do you come to the conclusion of these numbers? The 20% per year, it's going to be 13 billion per year, something like this.
Yeah. So we actually we put out our market report every 4 years, and that's kind of a key thing for what we do. We do incremental updates, in between that 4 year, but really we do a lot more extensive than just looking at websites and whatnot. We actually do interviews with those that are in the industry, particularly those that are in the different segments that we talk about. We actually talk to the CEOs and the investors in that space to really get a good idea of where those numbers are going, and what those numbers mean. And we poll out to the industry and see how do we build these numbers in place to make them really viable numbers. I think that's what really differentiates NeuroTech Reports from some of these other companies that are putting out market reports. Is they might be dialing for dollars and trying to find out where space is going, and they're making these projections off of past, which we're making projections off of past data as well, but we're actually going out to those that are actually in the industry and really understanding what they're seeing and what are the boots on the ground in terms of the growth that we're seeing in the industry.
And so actually you might be a really good person to ask this. So I've estimated the size of the community, something like 1,000 or maybe 2,000 people. How big do you think the brain-computer interface or neurotech community is?
In terms of the research world, or
if you could split it up, that would be more interesting. That would be more informative.
I don't even know, to be honest with you. From a research standpoint, it's definitely growing. So I can't tell you. I really can't tell you what this community is, but I'll tell you that it's definitely more than 2,000. More than 2,000. Yeah, you can definitely see that, because think about it. It's not just in the U.S., right? So there's a lot of research going on in Europe, in countries like Germany and France, the Netherlands, the UK, right? There's really, pockets of what's happening over there. We have Israel. There's some fantastic work being done over in Israel. There's work being done in Australia. So there's research institutions and companies that are operating out of Australia. And Asia is a growing market. South Korea, there's a lot of work going on there. In Japan, we're starting to see that. And, China is becoming a viable market. So it's becoming a worldwide market. It's not just the U.S. dominance. Whereas, U.S. is still a big piece of it, but I think it's growing around the world.
Yeah, that is something that I guess I came to terms with. I wanted to stay in Europe and do work there, but it was still it wasn't as well funded as the U.S. seems to be. But that could definitely change in the next few years. And then Asia too. That's always, that can. Well, I've seen buildings. I've seen videos of buildings being put up in 10 days or something like this in China. So God knows what can happen over there.
Well, yeah, but what things. We have to think about how the marketplace is changing, right? So over the years, we've seen the FDA, CDRH, which is the division that handles medical devices. They've done a fantastic job of working directly with the medical device industry. They also have a real push right now for consumer engagement and what they call patient engagement into that process, so that they make sure that the end user is involved in that process. So the FDA has also improved their response times. So they become much more responsive to the industry, right? What we're seeing happen over in Europe is that the CE mark, right? So their regulatory environment is changing. So in the past, it used to be, we have lots of research investment here in the US. You want to become a company, it's going to take you way too long to get approved through the FDA in the US. So instead, we're going to go over to Europe, run our clinical trials, get a CE mark, be able to get into humans, get it into the clinic, and then I'm going to take that data, come back to the US, and then I'll be able to get through the FDA. That's how it used to be. That is now starting to change, and we're starting to see it happen with companies. Because starting this year, the regulatory environment in Europe is changing. So they've changed the regulatory environment. They've become much more restrictive, and they're requiring much more to be able to get that CE mark. And that is coming. Some of it is here now, but it's coming even more. So you're starting to see companies change their strategy. They're not running over to Europe to get the CE mark. Now they're starting to actually stay in the US, or they're going to Canada, or they're going to another country and running their initial trials and then coming back to the US. So things are really dynamic right now, and they're really changing in terms of the regulatory space. Reimbursement is a whole other story.
Wow, yeah. Yeah, that definitely, I think America's, or US is the best for that, right? Like highest profits, something like this.
Well, one of the things we have to think about, and this is one of the hurdles that we have in the neurotech space, is that, and particularly in the US, is that we don't do our economic studies. We don't do them well here. And it's one of those pieces of the pie that we need to do much better. In Europe, because they have a different healthcare system, you see those economic studies, making the case for a device as to why economically it's better than another treatment that's on the market today. They're doing that because the governments still they're paying for reimbursement. So they want to see their return on investment if we invest into this device, because we need to pay for it as well. So those economic studies almost came with the clinical trials over in Europe. In the US, we always lacked that. We had it as two separate processes. One process of going through regulatory approval, one process of going through reimbursement. Now you're starting to see that the companies and the industry is now putting value on these economic studies, and because they have to be able to get reimbursement from our third-party payers here. Because you can't run a company if you don't have cash flow, right? I mean, that's the bottom line. You don't need an MBA to figure that one out, right? So, but what is key? What is key is that we're starting to see these economic studies now starting to take place here, and we're also starting to see the FDA and CMS, which is the Center for Medicare and Medicaid, starting to work together to try to streamline that process so it doesn't become a hurdle here in the United States.
Wow, this is fascinating. I don't think I've ever talked to anybody about this, so I don't know.
We're all focused on the technology,
exactly,
which is really a cool thing, and I mean, and that's part of the consumer engagement movement, right? So part of it was written into the 21st Centuries Act that recently passed, is to really push towards some consumer engagement, particularly here in the United States. And what does that mean, right? So what that means is we've operated so long in the neurotech space that we've got this really cool device, and now we're going to go put it on the market. Or where can I take this really cool technology to go solve a problem? And instead of, I have a problem I'm trying to solve, and let's create the technology for it, right? So we're trying to turn that on the head. So really the consumer engagement movement is really saying, listen, we need to go out to these end users the patient population, these consumers, and really understand what their medical needs are and what their daily needs are. Because if we just go to the clinical community, those physicians, albeit are very involved in the process, they only see that consumer for a short period of time. They don't have that lived experience, right? So how do we create a method or a mechanism so that those of us in the technology space can really understand what those needs are and help to build products and devices that are patient-centric? But then to go one step further, how do we create a framework so that once we build a technology, how do we validate that we're solving that solution? And then how do we build a framework so that as that product goes through the life cycle of getting it onto the market, that we have the end user, the consumer involved in that process so that we make sure that we're meeting those needs. So we're just starting that process. They're further along in the pharmaceutical industry. We're still at the early stages in the medical device industry. So you're seeing organizations like PCORI, which is the Patient-Centric Outcome Research Institute, right? We're starting to see MDIC, the Medical Device Innovation Consortium, really looking at a public-private partnership between regulatory and industry to be able to help understand this consumer process, right? So we're still at the early stages of this. I think actually Europe is a little bit further along in this movement. There's an area that's called UPATI, which is the European Academy for Training, Patient Academy Training Institute or something like that. But they're focused on how do we really engage the consumer, how do we train them on what the process is, and how do we get them engaged so that they're interacting with industry, they're interacting with regulatory, and they're interacting with reimbursement so that they're a piece of the puzzle as they move through that product life cycle.
Wow, this is fascinating. This is really, really cool. Yeah, let's talk about the neuromodulation space. What do you see in this?
Yeah, so the neuromodulation segment of the neurotechnology market is really kind of the bailiwick of, it's been the dominant piece for years. So
and maybe we can define it too, actually. How do you define neuromodulation?
So the way that we define neuromodulation is very simple. It's a device that modulates.
Oh, slow down.
Right? I know, slow down. Hang on a second. That's revolutionary, right? So it needs to modulate something within the human nervous system. And right now we're thinking in 2018, it's going to be about $4.7 billion piece of that business. And the dominating segment that's helped to grow this neuromodulation space has been spinal cord stimulation for pain, for chronic pain. I mean, the big gorillas have been in this space. Medtronic, Boston Scientific, St. Jude, which is now Abbott, have been in this space for a long time. The interesting thing about spinal cord stimulation, over the last probably about 3 years, there's a lot of more devices coming in to spinal cord stimulation, a lot more companies coming into this space. So those three are really starting to lose some of their market share to some of these other startups like Nevro, right? Like Nuvectra. So these companies are coming in, doing some new patterns, doing some new technology into the spinal cord stimulation space. So we're seeing that we're projecting it to grow at about 12%. But in this neuromodulation space, there's another segment that's growing incredibly well. We're projecting that it's going to grow at about a 46% rate. And that's the transcranial electrical stimulation market, right? It's stimulating our brains, right? So we're seeing that as a big growth area. Why? Why do we think it's going to be a big growth area? Well, we think there's two things that go on here. One is that this market has a lot of products coming onto the commercial space that are non-invasive. And it's going into two areas, right? So it's going into, how do we solve the mental health issue, right? How do we help people that have severe depression, people with OCD, with schizophrenia, with bipolar disease? How do we help them? Because right now there's a pharmaceutical piece, but that's a real problem. And potentially transcranial electrical stimulation might be able to help with that. anxiety, sleep disorders. I mean, there's a lot there, right? How do we help solve that? The other piece of that is the human performance piece, right? So we've seen some companies come on the market that are stimulating the brain to help our human performance, to help us in sports, to help us in terms of grades. You go on Reddit today, they have a whole way of how you can create your own transcranial stimulator. Just buy some parts you can get at Home Depot, which is a little scary.
That is
really scary. But the devices that are coming onto the market really have some viability, and they're getting some traction, and they're starting to sell direct to consumer. So that's why we're seeing this growth in transcranial electrical stimulation in the segment of neuromodulation.
Wow, that's incredible. Yeah, I heard the radio story about the lady that was doing sniper school, and then they turned it on, and she was just, you know, in the simulation, and she was able to pick off people and get, like, I don't know, 4 times better or something like this. So yeah, what are some big companies, or what are some big things that you see coming in this market?
I think there's some other pieces to the puzzle that are within the neuromodulation space. Peripheral nerve stimulation is another piece that we think is growing as well. Bioelectronic medicine, which I had mentioned before, we're starting to see a lot of investment there. And that really has some great potential, right? Bioelectronic medicine, the way that we're defining it is it's a piece of the modulation market. However, it modulates a human organ. So it modulates your digestive system, right, for obesity, or it modulates what we're doing in terms of your intestines or your kidneys, if you will. So it's modulating that human organ, even the heart, right? So we can potentially get to a space where we're modulating our human organs instead of taking pharmaceuticals to help solve those problems. One of the hurdles that we have to get over in this industry is what we call the last resort syndrome, right? This was coined off of cochlear implants, which are actually a piece of the neuroprosthetic market. But and whether you like them or not, Rush Limbaugh got on his radio show and he said, "Well, I'm going to go get a cochlear implant. It's my last resort." And that's where these devices have been sitting. Medical devices have been the last resort. Oh, I'll try all of these other things and then I'll get a device because that's my final piece. But we need to move up that ladder in the decision point. And we've seen some studies that help with that. So for instance, deep brain stimulation, right, for Parkinson's disease. A lot of times if you talk to people in the Parkinson's disease community, they're going to take all of the pharmaceuticals that they can to control their tremors. If they can't control that anymore, then they're going to go for a deep brain stimulator, right? It's the last resort device. But the early STIM study was a significant study that said, hey, listen, if we implant this device early in on your diagnosis of Parkinson's disease, we can actually slow the progression of the disease. An aha moment. This device really shouldn't be a last resort. It should be something that people consider early on, and that physicians are actually discussing it with their patients of, here is one of your choices. What are the choices that you want to make?
Wow, that's really cool. So you think this is the Parkinson's is the thing that's putting it ahead, not as a last resort, so that's kind of pushing it more towards early?
I think that was a significant study. I also think that there's a societal piece of this as well. We are becoming much more comfortable with having technology or using technologies with our bodies, right? How many people do we know with pacemakers, right? Pacemakers are incredibly common. So implanting medical devices we're becoming much more comfortable with, and we're also becoming much more comfortable with the fact that we can use devices on our bodies to help improve ourselves. So I think that's a real significant piece in terms of what we as society are willing to accept.
It's kind of a chicken and the egg. Like it won't be accepted until a lot of people do it, but a lot of people won't do it until it's accepted.
Right. But I mean, when we look at the neuroprosthetic market, right? So neuroprosthetics, the way that we define them is that it's a technology that either restores function of a limb or a lost limb, replacing for a lost limb. Or I wouldn't say an organ, I would say a function, right? So that's why in this space in neuroprosthetics, this is why we put cochlear implants in this space, we put visual prosthesis in this space. Even though it's sensory, it's not a limb, but it's really a function that we have in our sensory systems. And right now we're projecting that visual prosthesis is going to be exponentially growing at about a 70% rate over the next 4 years. It's an incredible growth space. When you think about our aging population and how they're losing their vision, if we can restore that so that people can keep their vision or have some form of vision, we're really kind of filling an unmet need. And we're starting to see more companies come out into this space.
Wow. What's allowing that actually? Like that hasn't been around for so long, right?
It hasn't, but we've seen the advancements of technology. That's a key piece, right? Of how do we build the devices so that we can restore vision. How many channels can we put into a chip, right? We've restored black and white, shades of gray movement, right? But now we have chips that can have more channels, so now we can pull in color, right? And we can start to restore color for vision. That's a key issue for people to be able to use these types of devices. There's a company called Second Sight that brought their device onto the market very quickly. They showed an unmet need. They are actually getting reimbursement for it as well in the U.S. and in other parts of the world. They're restoring vision for people that have lost it. So that's a really important piece. Another important growth area that we see in neuroprosthetics is robotic exoskeletons, right? We see these big clunky things today that we wear. That was actually grown, the first concepts came out of a DARPA project back in the 60s, right, to help with our military. Now we're seeing them used to help people with paralysis, whether it's from a stroke or from a spinal cord injury or from a brain injury. But we believe that the technology is moving forward enough and that we're able to get these devices onto the market that we're seeing a growth segment in this piece. But also the technology, as we drop it down, right? We turn from these clunky robotics into something that we can wear much more elegantly, that we can use out in the marketplace. Then we see that that's going to be a growth area where more companies are going to come in. In parallel with that, another segment of neurotechnology is neurorehabilitation. It's a very tiny piece of the market, but we also see robotics as a growth area for rehabilitation. Why? Because people having stroke, right? People having movement disorders, people having paralysis. How are we able to use these robotic devices to be able to restore function much more efficiently than we've been able to do before with just volitional control or with just contemporary physical therapy? So we see that as a growth area as well.
Wow, that's incredible. Yeah. So what's maybe like a personal favorite, or like what's exciting you the most, and what do you see having the most potential in all of these things, and generally in the neurotech space?
I think there's a couple of things that really excite me personally. One is the less invasiveness of devices. That growth of the technology, I think, is really exciting. Because, think about it. The device that I have, it took 7.5 hours to implant it. My second, device took 7 hours. Deep brain stimulations, we're opening up people's skull and sticking stimulators in them, right? When we think about that, that's invasive, right? So people are getting it, because they're seeing a true benefit. And really, so we can help understand the benefit versus risk. It's going to be different, whether you're somebody that's living with a degenerative condition or a lifelong chronic condition compared to somebody that's just trying to enhance their performance in their golf game, right? Their benefit to risk is going to be very different. So we need to help understand that. So the less invasiveness of devices, I think, is getting to be really exciting, and what that means is that also for implanted devices, so that we can come up with very simple surgical ways of implanting things into our body and being able to get the same function that we do today. So I think that's big growth area, and it's really, really exciting. The other piece of the puzzle kind of marries the neurosensing neurodiagnostics piece of the market with neuromodulation. And why do I say that is because I think a big piece of the puzzle that we can solve is with mental health and psychiatric conditions. The way that we diagnose psychiatric conditions, when you think about it, is really kind of, it's loose. It's not very scientific, right? I have you go into my office and I have you complete a questionnaire, right? And that's a snapshot in time, right? So I could be having a good day, I could be having a bad day when it comes to mental health. You're not seeing how do I go through this pattern to be able to make sure that I'm properly diagnosing a mental illness.
It's quantitative, or it's qualitative, not quantitative.
Not
right?
quantitative. So we're starting to see some of the neurodiagnostic pieces, some of the interfaces, the apps that we can use to help properly diagnose mental illness and psychiatric conditions. That's one piece of the puzzle. But then how do we treat it as well? So that's where we go into neuromodulation, into this transcranial electrical stimulation, into these other types of brain implants. That's a really exciting piece where we can now properly diagnose, and how do we properly treat that? So I think that's a really exciting growth area, because the brain is an organ that we really don't understand, right? We really, truly, it's kind of the frontier of the human body that we're still trying to understand. But I think if we can get our arms around diagnosis and treatment of mental illnesses and psychiatric conditions, I think we can make a huge contribution to society.
I can't wait in 20 years when we look back and be like, we did that? Like, that was so crude. It's kind of like bloodletting or leeches or something like this. And then we'll be like, we really just asked people like if they were depressed, and versus like running a diagnostic on their chip or something like this. So it is pretty exciting stuff.
That's an exciting piece. Yeah. Yeah. And I think, for me personally with spinal cord injury, I've been excited about the neuroprosthesis space for a long time, but I'm also starting to see two things happen. One is the spinal cord injury community is becoming much more receptive to technology and the use of technology, whether it's in rehabilitation or whether it's with a prosthetic or modulation. And I'm also seeing the research in terms of how do we restore function to people volitionally. How do we match the brain with an implant? How do we tap into this spinal cord so that we can restore function is really exciting, right? More research needs to be done, but I think personally from a spinal cord injury perspective, I think it's a fantastic space to be in.
Wow. And so what do you see kind of like the biggest challenges that we're facing, or that the community has to face, has to overcome in the short term and long term?
Well, what we're seeing today, one of the big obstacles for the neurotech industry, there's a couple of key factors. One is reimbursement. How do we get through the third-party payer process to make that economic value? That's a big hurdle right now for the industry. I think we're making inroads to try to solve that problem. We're starting to see some creative pricing models come out. I call it the printer model, right? So in the tech days of printers, which it still exists today, we sell the printer for really cheap, but we sell the ink cartridge for a lot, and that's how we make our cash flow. Some of these non-invasive devices, we're starting to see that. We're starting to see, oh, well, let's sell you the device, but then the treatments that you buy is where we create our cash flow. So reimbursement is a key issue, and how do we get around that? I think another one is actually training the clinical community, because a lot of clinicians are not taught technology in medical school. It really has to be a specialty or a passion of theirs to get into. So I think it's training the healthcare community to be comfortable with this space and be able to recommend and properly diagnose. So I think those are kind of the two big hurdles that we're seeing right now. But there's also drivers that's driving the growth. We're having an aging population, right? We're starting to see the regulatory environment become much more conducive for devices. We are starting to see the population to be able to accept technology. So I think there's hurdles, but there's also benefits for growth.
Wow. Excellent. Sounds like a great field to be in.
Well, we're starting to see, we always focus on the research and how exciting that is. But at the end of the day, we make lots of investments in research and technology. Our investments are thrown away if we don't get that technology to the people that can actually benefit from it. And why do we make those investments? Is because we want to improve the health of the people living with these neurological conditions. And the more that we can do to move the devices out of the laboratory and into the marketplace so that people can access them, the better off we all are.
Through that valley of death, right?
Through the valley of death.
Through the valley of death, where things they're on the bench. They work on the bench, but then to get it to the bedside, it's a bit of a gap, and in terms of funding and usability and everything like that.
So let's talk about the valley of death,
okay.
Right? So a lot of people don't know what the valley of death is. So typically a device is created into the laboratory. It gets proven. It's a little proof of concept. And now we have to get to human clinical trials. That's one valley of death of how do we make that transition from laboratory and animal models and modeling into a human. And a lot of times researchers are not willing to do that, or they don't have the resources to be able to do that. So what happens? That technology dies on the bench and it never gets into the human trials. So that becomes a key issue. Where do we need to make that investment? That's where NIH comes in. That's where private foundations come in. That's where some of the early investments come into these early stage human trials to be able to prove that it's a viable. We just lost a light.
We just lost a light.
Okay. This is how we create a viable device that says, yeah, we can go into humans. That's one valley of death. The next valley of death is, okay, now that we're in humans, how do we get over the hurdle to be able to make it a commercial device? That's a big valley of death. And there's a lot sitting on the bottom of that valley, some very viable devices that just have never been able to make it onto the market space. So what's helping with that? The tech transfer movement that we're starting to see, that tech transfer offices are helping with that. These incubators that are coming, that are growing in the area, these accelerators, these business accelerators that are starting to kind of help pull up some of these startup ventures to get over that valley of death and into commercialization.
Wow. Yeah, it's definitely necessary. And do you think that a lot of these companies at the bottom of the sea, like you said, could have been saved had they utilized the resources effectively, or do you think it was just inevitable?
I think the environment was different then. I mean, it really was. Let's take an exciting device that I was involved in. It's the OFS device. It was the Andera oscillating frequency stimulator for people with paralysis. That device had a proof of concept. They restored 1 to 2 levels of function for people with spinal cord injury, and they had the data to prove that. And they also restored sensation, right? So they had the data for that as well. The regulatory environment was very different then, and also what outcome measures that they used didn't meet those requirements. Because what happens is, and it can make it really complicated, but in evaluating spinal cord injury, it's called the ASIA scale, doesn't account for sensation. So how do you measure and objectively measure sensation, right? So one of the key things are, what are the tools that we use for outcome measures to be able to get through the regulatory process? We saw this with North Star as well. It was a device for stroke, and they didn't meet their primary outcome measures. So the company went out of business. Was the technology at a proof of concept? Did it help people? Absolutely. But it didn't meet those outcome measures, so the company went out of business. I think times have changed. I think our tools that we're using for outcome measures have changed. I think our environment has changed. So maybe there are some technologies that are in that valley that we can bring back out and can potentially be, key pieces. the book isn't written on that one yet. You know, that might be, hint, hint to those people out there that, well, entrepreneurs, there might be technology out there that already has the proof of concept that might be able to be
Pick
picked
it up,
up,
dust it off, and let's go round two.
modernize it and go to round two. You know, it might be out there. So.
Wow. Awesome. Awesome stuff. I've really enjoyed this conversation. Thank you so much. You gave me a book, actually. Do you want to plug the book, or do you want to just plug yourself on NeuroTech Reports, or how do you want to promote yourself, I guess?
Yeah, thanks. So NeuroTech Reports, we're at neurotechreports.com, and we focus again on industry and industry analysis. I've written 2 books. I've been an author of 2 books. One of them, Bionic Pioneers, which is a collection of short stories of the people that are on the front lines living with neurological conditions. People on the front lines working with living with neurological conditions, and these are the people that are putting their bodies forward to advance neurotechnology. So this was put out by a division of NeuroTech Reports. It's called NeuroTech Press. It's available on Amazon. And my personal story, On My Feet Again, is another book that I wrote. It's also available on Amazon, and it tells kind of my personal journey from injury to becoming living with a neural prosthetic.
Wow, excellent.
Thank you. Thanks for covering it.
Yeah, thank you so much. This has been excellent.